Hey guys, welcome back to Class Go Education. This is Gaurav, and today's PowerPoint is basically on nuclear power plant, lesson 2, nuclear reactors. So let us quickly start the presentation. So I have classified the nuclear reactor in following categories, that is boiling water reactor, pressurized heavy water reactor, light water graphite, gas cooled reactor, fast breeder reactors. Okay, so the nuclear reactor consists of three important things. One is moderator, another one is control rod, and third one is coolant. So basically moderator slows down the fast moving neutrons, and what control rods basically do, they used to absorb those slow moving neutrons according to the requirement. Okay, so let us just quickly see this chart. Okay, you just see the boiling water reactor and the pressurized water reactor both uses enriched uranium. Okay, and in fast breeder reactor, the last one, plutonium dioxide and uranium dioxide used as a fuel. Okay, and there is as a no moderator. Okay, and in the pressurized heavy water, we are basically using natural uranium dioxide. Moderator is heavy water and coolant is heavy water. You can pause down the video and can jot down the following details. Okay, now let us move to the boiling water reactor. So few important points of boiling water reactor is that one coolant loop is present. Okay, and the water is allowed to boil in the reactor itself. So there is a problem of direct contact which can result into contamination, okay, with the radioactive material. And the fuel used over here is the enriched uranium, and ordinary water is used both as coolant and moderator. Okay, so one of the advantage of boiling water reactor is that the elimination of heat chamber resulted in reduction in cost and increase of efficiency. Okay, so these are the points of boiling water reactor. Let us quickly go through the layout. You just see this is the layout. So in this layout you just see the control rods are there, and fuel, there is as such no heat exchanger. Okay, so heat is getting developed inside the nuclear reactor itself. Okay, so direct contact and the contamination issue would be there. Okay, so there is another layout of boiling water reactor, again the same thing, control rod, nuclear fuel, and the production of steam inside the nuclear reactor itself. There is as such no heat exchanger. Okay, so this is all about the boiling water reactor. Now let us move to the pressurized water reactor. So the few important point of pressurized water reactor is the coolant water is kept at a very high pressure so that it does not boil. So in a pressurized water reactor we are basically using pressurizer. Okay, the objective of pressurizer is such that the coolant in the reactor must not boil, okay, when the temperature rises. So the coolant should remain in liquid state in the reactor vessel itself. Okay, so in a PWR, the coolant water itself acts as a moderator. Due to these advantages, pressurized water reactor are most commonly used. The pressurized heavy water reactor is a nuclear power reactor commonly using unenriched natural uranium. Okay, and the heated water is transferred through the heat exchanger, where water from a secondary coolant loop is converted into steam. Thus the secondary loop is completely free from radioactive stuff. You just see the difference between boiling water reactor and the pressurized water reactor. The difference is this, that in the boiling water reactor you don't have any heat exchanger, but in the case of pressurized water reactor you do have a heat exchanger, which is considered to be a secondary loop. Okay, so this is the layout of pressurized water reactor. You just see the control rods are there. Okay, pressure tubes are there, fuel rods are there, heavy water moderator, pink color, that is also there. And you just see there is an extra auxiliary, that is heat exchanger, which is used in production of steam. So there is as such no direct contact with radioactive stuff. Okay, so this is another layout, the same layout. You can just pause down the video and draw this diagram in your copies. Okay, so now let us move to some key points of PWR. So there would be the concept of PWR, just I told you. There would be a pressurizer uh, which will try to make the coolant in a liquid state itself, and try to make the coolant not to boil, okay, when the temperature rises. Okay, and the steam generator rather of poor quality is produced inside it, that is around 250 degrees Celsius, and pressure is around 42 kg per centimeter square. So this is the Kandu type of reactor. Let us understand what actually the Kandu type of reactor is all about. So the Kandu stand for Canadium deuterium, uranium. Okay, so these reactors was first developed by Canada, and therefore the name is Kandu type of reactor. Okay, so these reactors make use of heavy water composed of the heavy hydrogen isotope, that is 1s2. The availability of heavy hydrogen exists in nature in the ratio of 1 to 6700, so it is a very costly affair. And one major advantage of Kandu type of reactor, you just see that there is as such no control lots. Okay, so I've explained all these points in the next slide. You just see the construction of Kondo type of reactor. Okay, fuel uranium, heavy water moderator is used, fueling machine is here, there, feed water is there, heat exchanger is there. Okay, so only thing is this, that there is as such no control lot. Okay, so these are the points of Kondo type of reactor. Okay, whatever I just explained, you can just pause down the video and can note down these points. Okay, the advantage is no control lot, so high multiplication factor and efficient fuel consumption. Now let us quickly move to the liquid metal liquid reactor. So these reactors basically developed to avoid difficulties faced in a pressurization of a water as in PWR, and at the same time retaining the advantage of having high temperature. So metal in a liquid state, you already know that it do have a good thermal conductivity, and high temperature can be had at moderate pressure. Okay, so but however handling the sodium introduces a difficulty, so it is also one of the issue. Okay, so in this particular metal liquid metal cooled reactor, you just see there are two loops. Okay, one is primary loop, you just see one is primary control loop, and another one is secondary control loop. And primary and secondary. So now let us understand what actually primary and secondary do. So sodium is circulated. So sodium basically, I should reduce the size of this figure so that now let us see. So sodium is circulated through the reactor core and an intermediate heat exchanger, where the heat from sodium is transferred to the sodium potassium, okay, liquid metal will and which gives up the heat in the heat exchanger to generate steam. Okay, because of violent reaction of sodium with air and water, the whole system should be leak tight. Okay, and the charging, discharging, or you can say charging and draining from one of the two loops should be done in the inert atmosphere to avoid the contact of sodium with air. So this is all about the liquid metal cooled reactor. I have explained some points in the next slide. So the difficulty of pressurizer and obtaining high temperature is resolved by liquid metal reactors. Metal in a liquid state have a good thermal conductivity, and high temperature with moderate pressure can be obtained. But one constraint to hold liquid metal activity, two heat transfer circuits are used so that radioactive sodium does not come in contact with the steam circuit. Sodium is circulated to reactor core and then to intermediate heat exchanger, whereby heat from the sodium is transferred to sodium potassium alloy, which further gives the heat to the heat exchanger. So this is all about the liquid metal reactors. Okay, and these are the sodium potassium alloy. Okay, advantages that alloy do have a lower melting point. Okay, and the major advantage of this steam generation is basically at high temperature and pressure, and there is very commonly used layout, that is sodium graphite reactor layout. Okay, and this layout basically uses slightly enriched uranium clad with stainless steel used as a fuel. Okay, graphite as a moderator and liquid sodium as a coolant. So you can just pause on the video and can write down these points. Now the last reactor is fast breeder reactor. Okay, so the breeder reactor is one that generates more fissionable material than it consumes. This is the definition, very crucial definition and important one. A breeder reactor is one that generates more fissionable material than it consumes. Okay, so these reactor basically converts the fertile material into fissile material. So these reactor requires fast neutrons. Okay, and two heat exchangers are used. The reactor which have a fissionable core, I will show you where is the fissionable core, where small fission material is placed. Okay, so fissionable core is there, which would be cooled by sodium or potassium. Okay, we will see that how the core is cooled by sodium and potassium. And in the second heat exchanger, the coolant is again liquid sodium potassium, which transfer heat to feed water to generate steam. So in fast breeder reactor, neutron shielding is provided by using boron, light water, oil or graphite. So this is the construction of fast breeder reactor. You see that point 1 that liquid sodium pumped through the baffle to be heated by the reactor core. Okay, so reactor core is there, that blue color one, and you just see that liquid metal coolant is pumped. Okay, is pumped inside this core, reactor core. Okay, and automatically you just see in the second step the heated sodium passes through the heat exchanger. You just see after the nuclear reactor, or you can say after this casing, that heated sodium passes through heat exchanger and containing more liquid sodium. So this heat exchanger, second number, it contains more sodium. Okay, and in third you just see there is another loop, third loop, where the liquid sodium from a heat exchanger heats water in a steam generator, and then this steam drives the turbine alternator set and produce electricity. So this is all about the fast breeder reactor. So there is another layout, very simple layout. I just told you that you just see that pink color one is the reactor core, which consists of a fissile material, that is over here it is considered that plutonium 239 is used, and with a blanket of uranium 238. Blanket is basically of fertile material, and the environment is basically that is liquid sodium. I just shown you in the previous slide, liquid sodium is pumped inside this reactor core. Okay, and then you just see that there are two intermediate liquid sodium cooling loops. One contains normal sodium amount, and in the next one, the second one, contains more sodium amount, and then there would be an intermediate heat exchanger which produces a steam for the steam turbine. So this is all about the nuclear reactors, and hope you have understood the concept, and please feedback, do recommend my channel, and thank you for watching. Have a good day.